Okay, hi everyone, and welcome to our AI Machine Learning Office Hours. It's February 15th. My name is Molly.
I can't hear anything.
Advisor.
Yeah, her internet's breaking up.
Oh no! Hopefully, at least the recording got it. Like I was saying, I'm Molly. I'm a student advisor for this course. I'm here at Springboard. We also have Dan, who's a mentor. Dan, you want to say hey?
Yeah, hey guys.
We have a couple students joining us in on the call today, so we'll just go ahead and jump into it before the conversation and thought thickens. But yeah, I wanted to welcome you guys to office hours and hope to see more of you join us. All right, go ahead and take it from there, Dan. Sorry to interrupt.
Oh yeah, sweet. So I had started to talk with Abhi about his project, which is really cool, and he's made some like awesome progress on it right away. But one of the things that Abhi had been thinking about is sort of as one of the next steps would be he's got this really interesting data set around app reviews. And so something that would be kind of fun to do with it would be summarization. So summarization is a task. There's some like unsupervised methods that you can use to do it. But if you want to use one of the more sort of exciting or newer sort of evolutions in doing summarization, you would want to use something like Google's sequence-to-sequence model, which has gotten famous for the ability to do translation between languages. So the way that it's doing that is it's doing basically parallel, encoding and decoding between basically pairings of text. So if we want to do summarization for Abby's problem, which has got basically a review, what we need some sort of a summary of what that review is actually saying. So there's people that have worked on this kind of like sort of problem or doing this sort of prediction in the past are working on things like Amazon's data sets, where Amazon has like, these long reviews with like, usually they'll have like a title. You can do prediction based on that title. But in your case, because you don't necessarily have a title for the review, it's a little bit harder. So it's kind of like puzzling around, like what are some ways that we could sort of construct or easily mine that, what that summary ought to be, because we could obviously do something like have a bunch of people go in and label it using Mechanical Turk, but maybe there's another way to get around doing it. Anyway, that's what I'm thinking about.
So in Amazon's case, the title they have done it manually, or
so in Amazon's case, it's just really intelligently set up. So if people have the ability to basically provide a title for what the review is going to be, then they're essentially giving you a short summary in that title. So what Amazon can do is Amazon can use a sequence-to-sequence model to basically provide the title in cases where people didn't do so, or come up with an assumption of what that might be. An analog to this would be something like if you had a bunch of newspaper articles and you wanted to essentially give them titles or give them some sort of like summary. Newspapers are typically written in the format where it's like that first sentence says everything that the article is really going to say. So sometimes there's the ability to do that, and there may be the ability to do that with your reviews, but it would require us to like kind of do an inspection of them and see if that pattern holds, because it may.
Okay.
But, yeah, I saw Lewis. You're here too, man. How's it going, dude?
Yeah, it's going well. Yourself?
Doing pretty good. I was talking with Abhi about his project a little bit, but what have you been getting into?
Yeah, no, I've been going over the mini projects that I had not done yet, so gonna be focusing on that lately.
Yeah, how have you found that so far? This would be like the data wrangling kind of stuff with Pandas or PySpark.
Yeah, I mean it's okay. It'd be more interesting if it was all related to one topic and broken into pieces. They seem to be unrelated in terms of the content, the data.
Okay, I see what you're saying. Like, so if it was like a single sort of like data exploration problem, and you were just learning to use the different tools around it, like kind of like more of a single thread.
Yeah, like after you go through the whole thing, you can see all the different parts of the workflow, but it ties back to the same problem.
Yeah, that's a really good point. I think that's true. Feedback for Springboard. But that's cool. Any questions or any sort of like ideas around that?
No, I think I already submitted one. I'm not sure if you got it or if the link I sent, if that's right. I'm not sure.
Yeah, I do get notifications as soon as
Okay.
I submit projects. So actually, I just wrapped up my my day job here, so I'll be looking at those later tonight.
Okay. Yeah, no, I'm finishing another one tonight. I was trying to do like one a day, but sometimes it's a lot of questions. So
Yeah, I was looking at them. They are pretty intensive. I guess the only thing that like I really, or not the only thing, but like one thing that I do really like about it is the fact that they're in that managed lab environment. So you're not like doing a bunch of time trying to set up the config of you know, a Spark environment yourself, because I remember back before there were like stuff like Domino around, like that would be like more of a pain than anything else, getting all the configs right.
yeah, sometimes I get emails about it being running for hours or something.
Oh, are you like keeping it on? Like you're not shutting down the instance?
Yeah, because sometimes I started at work and then I go home and I get emails about that it's running or something.
Yeah. Do you do much instance management like at your job right now?
No, I don't work with you know, any type of clusters currently.
Okay. All right. Well, that's actually like a really good learning point then. One of the like real things that people will be expecting from you as a machine learning engineer, as you work on these like extremely expensive, often like if you're doing a deep learning experiment and you're doing it over a cluster of GPUs that are each, you know, costing like, let's say $4 an hour, or something like that to run, it's pretty easy to think about how you could run up your cost very quickly. Or, I mean, even if you're doing it on-prem, like let's say that you own a bunch of GPUs, right? Your company owns a bunch of GPUs. If you're just leaving instances up, essentially in a running state, or you're hogging the instance so that other people can't get on it, that's very expensive for the company. So having good, I don't know what the right word for it is, basically good practices in terms of like, you know, my instance is up and I'm using it, or it's off and it's down. That's really good. And learning how to use automated tools to do that is obviously the next step. But
yeah, no, I thought I saw somewhere that after an hour it's supposed to stop, but I guess it's not happening.
Yeah. Okay. All right. Well, that's good to pay attention to.
Yeah.
Avi, you already work pretty significantly with AWS, right? It's certainly
yeah. By working on this project, yes.
Yeah. Okay. Yeah. So my experience has been that like at this point, like cloud is pretty like just commonplace, like across the industry. Like it's one of the things people just kind of assume, you know, which can be a bad thing.
I was trying to set it up, Keras on my server, and I had a hard time setting it up. So then I just launched a AWS instance and used that.
Yeah, are you using so if you're launching an EC2, they've got the deep learning AMIs?
Yeah, so I'm using the P2X large GPU.
Mm-hmm.
Yeah.
Okay, awesome. But were you able to get that up and running?
Yeah.
Okay, cool. Yeah, because this sounds really stupid, kind of embarrassing for me. But the first time I was playing around with Amazon's AMI, Louis, to give some context, the AMI is just like a machine image that they'll provide you so that because otherwise if you say you rent out this GPU like Abi's doing for his project, usually, or in the old days, you would have to get the right sort of Linux distribution on it. You would have to go and get all of the base supporting software that TensorFlow needs. So you have to go get CUDA, the right version of it. And then you have to bring in TensorFlow, the right version of it. And then you have to make sure they're installed correctly together so they're working with one another. And this is just for a single GPU. This isn't even a multi-GPU environment. So single GPU. And then you would have to, and then once you get all this configuration done, which is a pain in the butt, then you can finally start to play around with your experiment. And the whole time the GPU has already been up and running and charging you money. But so Amazon, of course, comes out with this Amazon machine image thing, which is not just for deep learning stuff, but it's just a nice process in general, so that you can easily basically get a software configuration onto your machine, however you want that set up. And they have them for deep learning ones. And so this is the first time I'm playing with it. And I had almost no cloud experience at this point. So I go in and I SSH into my machine, and it comes out and it prints out to you, and it's saying like, here's how you do your, Conda activation. So you can do your virtual environment with these various deep learning libraries. Like they've got, Theano and Chainer, PyTorch and TensorFlow and all kinds of stuff. And I'm like, great. And I try to do it. I try to do the command and it doesn't do it. It's like, I don't know what that command is. And so I'm like sitting there and I'm like, I must have spent like an hour just being so frustrated by like, what the hell? Like this AMI is not right. This AMI won't work. None of the, I couldn't get it to work. And of course the answer was something really stupid. Like it was like, at the time, it's like you had to be sudoed as root to get the Conda environment. And I was just being an idiot. So anyway.
Yeah, I had one of those recently that I needed
to.
Yeah? Yeah, I lost like 2 hours.
It's hilarious. But
it sounds that these images are different than when I set up a cluster, I can set up that configuration beforehand. And then I connect to one of the workers, essentially. Mm-hmm. Is that different than working with one of these images? It sounds like.
Yeah, it is a little different because like, a priori, there's not a master like slave relationship. You're just setting up an individual machine when you're interacting with EC2 in that fashion. You can I think you can use like EKS, and which is the Elastic Kubernetes service, where you could have individual nodes be GPUs, and then you would have something more akin to a cluster of GPUs working together. But if you're just interacting directly with EC2, no, it's going to be one instance at a time. And if you have multiple, they're separate from each other. So, but I was, did you guys hear about the Google, Uber's like newly released AutoML service?
Oh, no, I haven't.
Yeah, it's called Ludwig. I was playing around with that today. It's really cool. There's not like all that much like there's not that many examples for it yet because it's new. Mm-hmm. But the idea is basically to provide almost like AutoML kind of capability. Like Abhi, you remember the like Amazon Comprehend that we like looked at, where it was just like it just did it. So they have a very similar sort of like approach where it's like we want to basically make it really easy to train all kinds of models across all different sorts of machine learning tasks, and all you ought to really have to provide is the data set and basically specify which particular fields you're interested in training on, what you're trying to output, and then like some other config stuff. So
okay,
yeah, I was going to play around with that more tonight because it's like oh, this seems really cool, and I don't know how good it'll be like in terms of performance, which is one of the things I want to try to look at, but it would definitely be like really easy or really nice for like setting up baseline kind of activity.
Is it like the same as I'm not sure if you heard of H2O?
Yeah. So it's like an open source version of like H2O, where we use H2O at Aetna actually, or H2O, Data Robot. They're all very similar, and so Ludwig.
Data Robot, the diagram I'm looking at.
You're looking at Data Robot right now?
Oh no, I am looking at a diagram of Ludwig, and it looks like similar to Data Robot, where you just feed it the data.
Yep. Yeah, it's the same kind of principle. So it's like automated.
That's cool.
It's really cool.
But, and it's open source, right? So I don't need a license for it.
Yeah, you don't need a license, and it's like you're not getting, you can actually include it. And that is worth checking. I didn't check what kind of open source license it has, but I assume it's MIT or whatever. Let's see.
Yeah, everything is moving to be code free now.
Yeah, it's interesting. I was thinking about that. I was reading this book actually, which I would recommend to you guys. Actually got it right here, which is it's called Pragmatic AI. Where's that book? Right here. But so like me and Abhi were talking a little bit about this. I'll like put the link in the description, or I'll send the link out to people. But anyway, me and Abhi were talking about this list, which was like, so what you're learning, like what we're focusing on in this class is going to be more on like the development development and deployment of solutions yourself. So it's like a lot more of those sort of like building from scratch kind of activity.
Yeah.
But one of the things that's like really important, either if you're someone like Abhi who's got goals to like, basically how do I use ML to, to build a business, or if you're trying to work in industry like yourself, one of the things that's really important to be able to do is to know when it's good to buy versus build, or rent versus build. Because if you think about it, if like the average salary for like an ML engineer is like, let's say it's like $150,000 a year, right? And you've got a team of like 4 or 5 of them that are working together. And you're going to say that, the given projects, like, from ideation to deployment, and we'll say there's some upkeep and whatever else. So we'll say it takes like, like a year or whatever, right? So it's like $500,000 that you're spending on a particular service. So that's a big investment. Like, and companies know that. So as an engineer, like one of the things that you can do that's really valuable is understand like when does it make sense to basically utilize someone else's service that's like an API that they've given you, or utilize tools like Data Robot or H2O. And when does it make sense to build your own model from scratch? Because there's kind of like competing trends there. So anyway, I really like this guy's book. He's like I forget what all he's done, but he does like a really good job of showing. He's like very AWS focused, but he does a really good job of showing how to utilize like all the tools in the AWS ecosystem to like basically just make yourself more useful as an ML person, which is cool. Because I feel like this course probably we don't cover all that much of that. So yeah, I've been talking a lot. Do you guys have any questions or?
I have one question regarding the model that I'm building.
Yeah.
Do you mind if I share it? Or?
Yeah, man. Let's take a look at it.
Okay. I just, while you were talking, I just brought my AWS instance up.
Oh, cool, man.
So can you see it?
Yep.
Okay. So what I'm trying to do is, while I was trying to learn Keras, what I did is like I was trying to do the same classification thing. Okay, and so far what I've done is so this.
I'm getting some weird feedback.
What is that?
Is anybody else getting weird feedback?
Yeah, like you're cutting off.
Oh, is it?
Yeah.
How is it now?
Yeah, now it sounds fine.
Yeah, it's better now.
Okay, so I read the data, and before that, what I've done is like as I told Dan you that I have built a word embedding model.
Mm-hmm.
Right. So where is that? So here I'm reading that model in as an embedding layer.
Mm-hmm.
Okay, and then I'm trying to build this classification model using all these different layers. Okay, so this is a sequential model that you were talking about earlier.
Yep.
So I mean, I ran it for 2 epochs, and I got very low numbers around. So here is a number, just 2 epochs. It is around 20%.
Mm-hmm.
So just wanted to check with you if I'm doing anything wrong while setting up the model here.
Right. No, so you're doing talk me through the kind of model that you're building.
What is that?
I was going to say, talk me through the kind of model you're building and why you're choosing the nodes that you're doing. So I'm seeing that you've got a one-dimensional convolution followed by some pooling and then an LSTM node, right?
Yeah.
Okay.
So what I'm trying to build is giving it an embedding layer of my own, which has my own weights trained, right? And I was trying to see if I can basically build the same classification model, basically classifying the ratings for each review.
Right.
I don't understand yet because I'm still reading upon all these, how to optimize all these different layers.
Mm-hmm.
But I was just while reading as well as trying on the side.
Yeah. So let's first look at your accuracy, right? As you were going down, because I was intrigued by that. Okay. So what made you decide to run 2 epochs?
It was taking too much time. So
Much time. Yep.
that's why I just, and it was not improving. I let it run for 3-4 hours. The accuracy was still the same.
Okay. All right. So when we go back up and we look at the total number of basically like training parameters that we have there, that's a huge number, right?
Which one?
We've
This
got
one?
12 million right there. The training parameters, the trainable parameters, it's like 12 million. It prints out there.
Which is 127. You're talking about the 127 box?
I'm looking up. Yeah. Above the 127 box.
Okay. Oh yeah, this one.
Yeah. So we've got a large number of trainable parameters there, which is why it would be very hard for it to learn something, and then two, it's going to take a while to do it. So I guess my first thought would be, let's think about what is the sort of model that we've seen other people use, or have we seen other people do the similar sort of task? And if they have, what kind of model did they use to do it? Because otherwise, there's so many different possible node configurations or networks that we could build, architectures that we could build, that searching over them or just trying different things is probably going to be really hard to be successful at. So I would say the first thing I would look to do is I would say, what is my task similar to? So it's a classification task, right?
Yeah.
And it's not really all that different once I have my my initial shape is created, which actually, so I'll have to look at it deeper. But so when we're looking at our first layer, that would be the first thing that I'd be kind of, I guess, interested in is, are we training it on a single vector here, like some sort of a mean that we've computed, or are we training it on a sequence?
So it's a sequence of 500 words.
Okay, yeah. So that's probably going to be a lot. Maybe we could try training it on some sort of a subsampling or something like an encoding of that's smaller first. That would be an option to try to reduce the total number of parameters.
Yeah, try playing around with 100 also. I was still getting the same thing. But of course, the word embedding vector matrix is very, very big here, because I trained it on 8 million views, and then I got that word embedding model, word embedding matrix. So I'm feeding it all the weights in the first layer with the word sequence of 500
Okay.
per review.
Okay, so that gets to an interesting question too. I guess there's a lot this is bringing up for me. So if you've got to basically state that there's some fixed basically size of that initial node, right? So that initial layer. So if you pick 500 words, like what do we do when we have a review that's shorter than 500 words? Is it just with some average vector following after it, or what's the strategy?
That I have not taken into account here.
Okay.
So I'm not sure how the model will handle that.
Okay.
You mean the short reviews, right?
Yeah. So if we have an embedding, or not an embedding, we have a review which is, say, 20 words long.
Yeah.
Right?
Yeah. But I have padded everything with up to 500. So max length is 500. So zeros. So I padded with zeros.
Okay.
Yeah.
Okay, that could be it. That could be interesting, right? So what's your average review length?
Average review length is around 150.
Okay. And then the like your min and maxes are like what?
Min, it could be one word only, like awesome.
Okay.
Yeah. And max I've seen above 1,000, around 1,500.
What?
Yeah.
That's insane. Okay.
Yeah, but they are not that many.
Yeah, right. Okay. So yeah, this was actually a really interesting point. So in general, I would say that one of the first things I would kind of think of is if we've got if we've got a bunch of space which is being essentially occupied by nothing, right? And there's a tiny little bit of signal in there, that's going to be really hard for the model to basically pick up on.
Okay.
The more that it's funny because in some senses, people are like, well, with a neural network, you don't have to do any feature engineering, don't do anything to think about that. But it's not
That's
really
what I was looking for.
Yeah, that's not really true. So probably thinking about how we construct that input to it is going to be a really good first step. And then as far as what the actual model architecture looks like, I'll look around a little bit. And I mean, before we have our next call, let's pick out some papers that other people have written, like researchers have written, and then we'll look at the architectures that they've designed, and we'll probably use an architecture that they have because, if one of the beautiful things about these libraries is it's very easy to create your own sort of architecture, but the reality is that there's many ways to create something that just doesn't really learn anything.
Okay.
We'll look at some, and that's pretty common practice for like machine learning engineering is to be like, what have other people done? Okay, can I find something that a researcher has done that has really good performance on a benchmark that's similar to my problem, and then I'm going to implement that. It's pretty rare for you to be in a situation where you're going to be essentially just writing your own from scratch or from intuition. Because if you were really, really good at doing that for just randomly hard problems, then you would be in a really interesting career field.
Okay. Yeah.
But,
I mean, if you come across any papers, just send me through. I'll read one back.
Yeah. I was going to say let's we can plan to basically like read them beforehand before our next call, and then we'll kind of talk about them and see what it would look like to implement them. So.
Okay. Sounds good. Thanks.
Yeah, no problem, man.
Last chance for questions because I do believe we're almost at time. But yeah, great questions today and really enjoyed the conversation. And thanks so much for sharing the screen and kind of being able to showcase what you guys have been working on, questions you guys have had. So giving chance for maybe one or two more questions, and then otherwise, I think we will be having another mentor joining us for office hours next week. The exact mentor is to be determined. However, I believe we'll be having one of our Springboard mentors joining us. So bring your questions that you might have for someone else. I know Dan's been great at answering questions so far, but just to get someone else's perspective and ideas, we'll be having them join us as well. I'll be posting that in Piazza as soon as we lock down the exact mentor class.
Okay. Thank you.
Awesome. Well, thank you guys so much for joining us today. Really appreciate it. Thanks, Dan, as always, for your great answers and help. I hope everyone has a good rest of their week and a good Valentine's Day, and we'll see you guys back here next Wednesday.
Yeah, sounds good. See you guys later.